Hello everyone! In this video, I want to provide an introduction to Lambda functions. Let's start by reviewing what a function is in Python. Well, a function is a named sequence of statements that implements one algorithm or solves one problem. It starts with the keyword def. So let's start by coding up a very simple function called myDouble. MyDouble is going to take a value x, attempt to multiply it by 2, and return that result. So x could be an integer, a double, a string, etc. So as we know, we can call this function by passing in a value like this. And let's just print out what result we get when we pass in, say, 2. We should get 4. 2 times 2 is 4. Okay, let's try maybe 5. 2 times 5 is 10. Perfect. You'll see above this function that I have a comment here that a function is an object in Python. This means you can use a function like a reference. So let's take this one step further and see that we can actually use myDouble like a variable name. It's an identifier. I could have, say, a variable called myFunc, my function, and I could assign it myDouble. Note that I don't have an open paren or a close paren here. I'm not calling the function. I'm just using it as an identifier, as its name, so that essentially my function is a reference to the same object that myDouble refers to. And that object is a function. Just some executable code in memory. So now this is going to look kind of crazy, but I can call this function using myFunc. So let's say I pass in 10. I should see 20 printed out because myFunc is an alias. It's an alias for the same function that myDouble refers to. This idea of a function being an object in Python is really important for our conversation we're about to have about Lambda functions. So a Lambda function is a function. Don't let the fact that it has different syntax confuse you. It is still a function. It's just a function that doesn't have a name. Lambda functions are also known as anonymous or nameless functions. Anonymous function is a name that you might have heard of if you're coming from a different programming language, maybe like Java or Swift. Okay, it's a function that doesn't have a name. And it's meant to be kind of shorthand or kind of syntactic sugar in your code, where if you just need to do something really quick, or maybe save that doing something quick for later, like a callback, use a Lambda function. So since a Lambda function is just a function, you can have a reference to a Lambda function object, and you can pass that reference around in your code so that the function can be executed at a later time. We're going to see some examples, of course, of Lambda functions, but let me just say a few more words about it before those examples. First off, Lambda functions are single line statements that typically return a value. An example would be lambda x colon x plus 1. So this is just one line. It starts with the keyword lambda. That's how we declare a lambda function, a function that has no name. Then we have the input to the function. So this is essentially where we put our parameter list. So here we have 1, x. And then we have a colon, and the colon separates the parameter list, or the header, if you want to think about it that way, from the body or the actual executable statement that typically uses your parameter list. So we have x plus 1. So essentially, this is a simple function that accepts an input and returns 1 plus that input. Typically, this kind of syntax, or the idea of Lambda functions in general, are used for performing short operations, like adding 1, doubling a number, or really quick data manipulations. You'll see them a lot if you are studying data science and or data mining and or machine learning, because we need to do something really quick and we need to apply it to, say, every value in a list or a series or a column in a data frame. All right, time for some examples. So let's start with a very simple function called say, and say is going to accept a parameter. We'll call it message. This could be really anything that's printable. And we're just going to print out that message. So now I'm going to define another function that can execute any one string argument void function it is passed. So this is going to look kind of strange, but essentially we're going to have a function that accepts a function as an input. We'll store that function reference in this parameter here, f. So f is a reference to a function object. Okay, remember, we're a little bit familiar with this idea from our demo up here. In the body of this execute void function, I am going to call or invoke f, whatever function f refers to, and pass in the string argument hello. So now we're going to call the execute void function, passing in the say function reference. So execute void function. Okay, I'm going to call the function on line 21, and I'm going to pass in the say function. Note that there's no open paren, close paren. I'm not calling the say function. I'm using its name as an identifier. This is a reference to an object. I'm passing in that reference. At runtime, f will refer to this function. It'll become an alias for the say function. On line 22, we'll execute it, passing in hello. So now when we run this, we should see saying colon space hello. And there it is. Hopefully, these two functions make sense, because now we're going to call execute void function again, this time passing in a lambda function, a nameless function, instead of one we've already defined and given a name using the traditional def syntax. So execute void function. We start our lambda function with the keyword lambda. Then we have our parameter list. There'll be only one parameter here. This will be a string or something printable. And what we'll do is we'll print from lambda, and we'll print out that value, whatever's passed in. So now a reference to this lambda function is going to be passed in and stored as f when this function executes from the call on line 27. And we should see from lambda, hello. And we do. So now let's move on to some common applications of lambda functions. We're going to focus on map, filter, and reduce functionality. Map, filter, and reduce are common operations that you'll see when working with data. With map, we're going to map a function to each element in a sequence to produce a new sequence. With filter, we're going to filter elements in a sequence by some criteria to make a possibly smaller sequence of elements. And with reduce, we're going to reduce all of the elements in a sequence to a smaller dimensional item or sequence. So to get started, we'll need a sequence. Let's keep it simple and have a 3-item list, 3, 4, 5. We'll print it out so we can refer to it easy in our output and see if our map, filter, and reduce functionality is working. So let's start with map. So with map, we map a function to each element in a list. So for example, let's say I'm going to call the built-in map function in Python, pass in a function that I want to apply to each element in iterable. So let's use myDouble. It's not a Lambda, it's a standard function we wrote at the beginning of this video, and we want to map the myDouble function onto each element in nums. This is going to produce a map object, but we can quite easily convert that map object back into a list by passing it to the list initializer. So if I print this out, I see 6, 8, 10, which is 3, 4, 5, where each element has been doubled. Now, let's rewrite this line to use a Lambda function instead. So Lambda x, where we multiply x by 2. We should get the same output, which we do. But here we've used a Lambda function instead of a standard function. Next, let's move on to filter. We're going to filter elements in a list by some criteria. Let's start by solving this without using a Lambda function. We'll use a standard function. Let's say we want to filter nums to only include odd numbers. So I'm going to have a function called odd. It's going to accept a number and return true if that number is odd. It's not divisible by 2. So I'm going to call the built-in filter function in Python. So I'm going to pass in the function. It'll be a criteria function. So it'll return true or false if an element should be included in the resulting filter object, which we can convert to a list. And then the iterable, the list that we want to filter. So I'll pass in odd and I'll pass in nums. And we'll print out our result here. And we should see just the odd numbers in our list, which would be 3 and 5, no 4. And there we have it. Let's solve this again using a Lambda function. So I'm just going to rewrite that odd function to be a Lambda function. And there we have it, the same output. The last operation that we'll look at is reduce. So with reduce, we reduce elements in a list to a single value. Reduce is not a built-in function like map and filter, so we will need to import it from functools. All right, so let's write a function that accumulates all of the values that it has seen so far in a list with the goal of totaling them all up into a sum. So this function will accept 2 parameters. The first one will be the total that it's seen so far, and the second one will be the current element. So it's simply going to add these 2 together and return. So you can imagine this function being called on each element in a list, accumulating all the values it's seen so far, plus the current one, and then moving on to the next one. All right, so let's call reduce that we've imported from functools. So what we're going to do is we're going to pass in our reduce function, which we called total. And then we're going to pass in our iterable, which is nums. And we'll print out the result. So essentially this should be 3 plus 4 plus 5, which is 12. And we get 12. Now, we want to call this function again, but instead of passing in a named function like total, we're going to pass in a Lambda function. So I'm going to rewrite the total function to be a Lambda function. So it'll have 2 parameters, the total so far and x, and it will return the total so far plus x. I should get the exact same output, 12, but this time I'm using a Lambda function instead of our named total function. Now, I'll mention that this reduce function does have an optional keyword argument, initial, which is if you want to initialize the accumulation variable to start at something other than the first element in the iterable, you can do so. So now I'll leave you with some practice problems that I encourage you to try out to practice with Lambda functions and map filter reduce. Let me zoom out a little bit here so you can see everything. There we go. So assume we have two variables, nums, it's a list of integers, and sentence, it's a list of strings. Try to write a Lambda function to do each of these tasks. The first few use nums, and the last few use the sentence variable. And then I have a little hint down here for the last one, which is a little tricky if you're not familiar with the built-in function sorted. All right, I hope this was a good introduction to Lambda functions. Remember, they are functions, they just don't have a name. Functions in Python are objects, which means that we can have variables, aka references, to those objects, and we can pass them around in our code to be executed at a later point of time. Try out these practice problems to see if the idea of Lambda functions and map filter reduce is making sense. If you have questions, feel free to ask them in the comment section of this video. Thank you for watching.